let's talk about scopes. I'm going to make a variable a to be 1 and make a function foo whose body is a plus 1. Naturally, when we call foo, its value would be 2. I can make another function bar which simply calls foo, and of course it will return the same value 2. Now I'm going to define a local variable a and make it 2 and add that to the return value of foo. Now foo still returns 2, so the result now would be 4. These concepts may seem pretty basic to most programmers. However, the last result is actually not a given to all programming languages. So let's take a closer look at what's really happening with regard to scope. I'll use colored rectangles to represent scopes. And here's our top-level scope. Assignment puts things into a scope. In our sample code, there are 3 assignments. Among these, A is the simplest. Closures and functions comes with their own scope. Let's use green for foo and red for bar. Bar's body has an assignment, so it gets something in its scope. Expressions in function bodies gets evaluated in their own scope. And that just means it will look for variable definitions in its own scope first. If the variable is not there, then it will look outward in its parent scope. That's how A in foo's body is determined to be 1. The A in bar has a different story. Because the local variable can be found in the scope created directly for bar. In contrast, we have to go to the parent scope to find foo. Having rigorous analysis and understanding of scopes enables us to represent them with our own program, and that would be an even more precise form to represent this concept. So I'm going to use the class environment to represent a box. An environment holds a map from symbols to values. An environment can have a parent environment. Because this is a Swift class, so I'm going to have to write an initializer. I'm going to use a subscript as an interface for accessing the environment. When something is not present in the environment, we'll return nil for the reader. When we need to look up something, we first check whether it's in our own environment. If not, then we'll go to our parent and see if it's there. And this is a recursive process. Putting new things into the environment is pretty straightforward. And that is our in-memory representation of the concept of scope. To be more precise, this concept is static scope. Remember how foo always returns 2 no matter where we call it, even in the body of bar where A is defined to be a different value? That's where the word static comes from. If we write this program in eLisp, for example, foo could return different values depending on what the most recent definition for A is. In other words, when we call foo in the body of bar, eLisp will not do what the leftmost arrow indicates. Instead, it will think A is always 2, therefore foo returns 3. And that's what we call dynamic scope, not static scope. That's all for now. Thanks for watching.